Neil Pettinger, would you like to say a bit about yourself, and then I get on with your presentation today, which is about exit block, isn't it?
It is about exit block. Thanks, Rachel. And just going back to what you said about questions and stuff.
Yeah,
So this is what I'm sharing today is it is work in progress. So I'm looking very much looking for comments and
yeah,
um, criticisms and suggestions from people um, on a range of issues. So you'll get the
good.
gist from the way that I present this that it is a work in progress.
Yeah,
So yes, please feel free to ask questions and pose them, and I will definitely endeavour to answer them if we don't have time to do them in the hour
thank
that
you,
we've got allotted.
thank you.
Right. So I'm Neil Pettinger. I'm a freelance healthcare data analyst who mainly obsesses about patient flow. So patient flow is my kind of specialist subject. But I also do training courses, and some of you I will have met on training courses where I do stuff on stats and R and kind of data storytelling. Um, so I do that as well. But today I'm going to be talking about flow and one particular hypothesis in particular. What I should also say as well is, yeah, I haven't always been freelance. I used to be a proper NHS data analyst, you know, salaried and all that. But it's been a long time since I did that for real. So that was probably about 17 or 18 years ago that I gave that up and have been freelancing ever since. Right, so that's me. So what I'll do is I'll share my screen so that you can get a sense of what the topic is in this bizarre, slightly, there we go. Is that full screen? Is that visible so that
Yeah,
people can see it? Is that
that's
good? Right,
perfect
okay.
for me. Yeah,
So there's this ridiculous title, Heaviness Past, Heaviness Present and Heaviness Future. Um, and the subtitle is probably a bit more helpful, Measuring, Describing and Finding Solutions to Exit Block in Acute Hospitals. Um, the heaviness past, heaviness present, heaviness future. So we do need to get those terms right first. So when I was compiling my sort of structure for today, I sort of created a little agenda, which if I get my screen right, you'll be able to see. So here's the agenda for today. We've got it in 7 parts. So Rachel, you can take a screenshot of that and make sure that I'm vaguely running to time. Terms and conditions, what I mean by that is just defining my terms. In particular, what do I mean by heaviness and what do I mean by AMU and stuff like that. And then I'm going to talk a little bit in section 2 about, so this is section 2 in particular is for those people who don't work in acute hospitals and don't have the sort of familiarity with the way that unscheduled care patient flow works. So I've got a diagram that helps to take us through that. And then I'm going to talk us through, again, it's even more enigmatic terms, the flowology grid, even more enigmatically, the gold run. So anyone who's old, like me, will remember a show on Channel 4, I think it was, called Blockbusters. I think we're going way back to like the 1980s here. Anyway, that'll be a trip down memory lane for the oldies amongst us. And then what we're going to do is spend probably the guts of the time on this notion of fullness and heaviness. And then we're going to hopefully have time for questions, comments, and criticisms. So that's the plan. That's the plan. There is structure to this. Terms and conditions. Well, before we get to the actual fullness thing, it struck me that when I was coming up with this idea of heaviness past and heaviness future and heaviness present, I realized that I'd missed a trick with my terminology. And then someone pointed out to me that there's a Dickens Christmas Carol analogy here, which I was actually unaware of. So I had to do a little bit of Wikipediaing. So there are these 3 ghosts in Dickens' novel, A Christmas Carol. And I did a little Google image search to try and find the original illustrations. The Ghost of Christmas Past. Well, I think that's actually Scrooge on the left, who's like getting rid of the Ghost of Christmas Past. The Ghost of Christmas Present is that kind of jovial looking chap in the middle of there. And Christmas Yet to Come is that sort of rather, is that a kind of doom-laden sort of warning for Scrooge as he mends his way? That's anyway. So that's obviously maybe future should have been sort of yet to come instead of future. So what I mean by so let's move away from Dickens and let's move to the 21st century. And what I mean by heaviness is this. So what I'm going to do is I'm going to introduce you to this graph, which I hope you can see. And hopefully it's big enough so that you can get see what I'm getting at. So one of the things that that bothers me about patient flow in hospitals is how we describe length of stay in a way that has some sort of resonance for clinicians, and in particular for the doctors whose patients they are that we're describing. And I had a few conversations about a year ago with some geriatricians, and one of the things that they sort of told me, as they sort of made it clear to me, is that when they think of length of stay in their mind's eye, particularly when not the length of stay of a particular patient, but length of stay in general, what they're often thinking about is the length of stay of the patients who are currently in hospital. So let's imagine that you're an acute medicine consultant. So you're imagining the length of stay of patients in the AMU. So that's the acute medical unit. So that, again, for those of you who are not ultra familiar with acute hospitals, that's the sort of main admissions ward that patients go to. Is the first port of call for anyone who's deemed to be an emergency medical inpatient. They nearly all go to the acute medical unit. And the idea of an acute medical unit is that it's usually quite a short stay ward, and you either go straight home from there if they can sort of deal with you in 24, 48 hours, or if you need to move on to a downstream specialty ward, they decide in conjunction with the specialist which one that should be, and off you go. So what I've done here is I've taken a snapshot of this acute medical unit at midnight, or not midnight, sorry, midday, I should say, 12 o'clock midday, on the 25th of March, 2024. So this is real data from a hospital that's anonymous. And I've done it as a sort of almost like as a kind of Gantt chart. So what we've got here, there are 58 patients, so there are 58 horizontal lines. And they are ordered, the patient who's got the longest length of stay so far is at the top, and the patient who's got the shortest length of stay so far is at the bottom. So you can see there's a patient there at the bottom who must have been admitted at about, 11:30 or 11:45. So they've only been in for about 15 or 25 minutes. Whereas the patient at the top was admitted about a week ago. And when I spoke to doctors, so I mean, I was speaking to geriatricians, but I might as well have been speaking to doctors. This is very often the way that they visualize it. It's the length of stay so far of patients who are currently in hospital. And the reason I've called it heaviness here is because what we can do with this data is that, can you see that if we think about that snapshot in time, 12 midday on the 25th of March, 2024, so 18 months ago, then we can look, say, not just what was the length of stay of those patients so far. So the length of stay, the average of all of those blue horizontal lines is 47.6 hours. But what we can do is we can multiply that those length of stays by the number of patients in the snapshot. So we're effectively getting the occupied bed days, or occupied bed hours would be more appropriate, because in acute medical units they tend to measure length of stay in hours rather than days. So if we multiply the number of patients by the total number of hours that are generated, which is effectively represented by the amount of blue ink on that diagram, we get to an accumulated bed hours weight of 2,761. And I call that AMU heaviness. And that was me, when I came up with this, I came up with a way of visualizing. That was me just thinking, well, this is how I think you see it. So let me try and describe that. And then I realized that there was another way of looking at length of stay, which is hopefully going to be the next slide. There we go. So this is heaviness yet to come. So if that previous slide there was heaviness past, so that's the length of stay that has been generated already by the patients who are in hospital at 12 noon. What we've now got is we're taking the same snapshot. So these are the same 58 patients, but they've been ordered differently now. So they've now been ordered by the length of stay yet to come. So obviously you can't do this. You've got to wait a while before you can do this analysis, because you've got to wait until all the patients in the previous slide have been discharged from the AMU. And then once you've got that, so once you've waited a week or whatever it is, you can do this and you can say, right, okay, if we take those same 58 patients who were captured by that snapshot at midday, how long did they still have to stay in the AMU? So in this particular example, it was a bit shorter. So the average length of stay still to come was only 31 hours. Remember, it was 48 hours in the previous one. And therefore, when you multiply the length of stay still to come by the number of by the 58 patients, we get a smaller number of bed hours still to come. So that's 1,804. So let's just do a quick comparison again. So that's the past heaviness, and that's the future heaviness. And hopefully you can sort of see why I came up with this word heaviness. But although this is one of the things that I do want to ask for help with, because I'm not sure it's a great word, it's the idea that you can put those two graphs on a set of weighing scales, and the red graph will be lighter than the blue graph, okay, because there's less red ink. So it's this idea that if you measure the future heaviness of the AMU, it was lighter than the past heaviness of the AMU. And one of the things that I'm still exploring and still want to explore in a bit more detail is, to what extent can we generalize? Is it always the case that, future heaviness is lighter than past heaviness, which I very much doubt? And are there patterns through it? But as we'll explore this, we're also interested in what the relationship is between heaviness and other things. So that's heaviness and future heaviness. So that's the main thing I want to get to, because we're going to come back to this. Heaviness present, of course, is the one that I haven't mentioned. So we've done heaviness past, heaviness future. Heaviness present is when you join the two together. Now, confusingly, okay, it would have been great, wouldn't it, if I'd had a slide that was using the same midday snapshot, but for reasons which have now escaped me, I'm actually taking a different snapshot at a different midday in the same month, March 2024. But it doesn't matter. Hopefully, you've got the hang of this now. So what we've got here is the blue horizontal lines, which are the length of stay of the patients so far. The red are the length of stay of the patients that's still to come. And if you add them together, then that's what I call heaviness present. And again, that will rear its head a bit later in the presentation. So 3 ways of thinking about length of stay: heaviness past, heaviness future, or heaviness yet to come, and heaviness present. Okay, so that's what I mean by those terms. And at the moment, it will seem a little bit theoretical, but hopefully it will kick in as relevant a bit later on. Now, the unscheduled care pathway diagram. So again, conscious that people might not be familiar with acute hospital pathways. This is a diagram that was drawn for me in my notebook by 2 acute medicine consultants at Raigmore Hospital in about 2012, and it stood me in good stead for the 13 years since then, with only slight modifications. And I've tested this on all sorts of people who work at front doors and hospitals. So drastically oversimplified, but essentially the unscheduled care pathway, in terms of how it works, in terms of patient flow. Patients come in from the left, they come into the emergency department. A good chunk of them will be discharged home from the emergency department, obviously. So in a typical general hospital, there'd be about 70% of the A&E attendances will go home from the A&E department, with only about 30% being admitted. And then the acute medical unit is in most hospitals the main next port of call for those patients who need to be admitted. So of those 30 patients that need to be admitted, usually at least half of them will go to the acute medical unit. The remaining half, I haven't given a box to the others. They will go to surgical receiving unit. They will go into orthopedic wards. They will go into gynecology. They'll go into pediatrics and so on. Some of them will go straight into critical care. But the big one, and again, I've sort of tested this by lots and lots of conversations with people who work in EDs and AMUs. The main one, the one that causes the real problems in terms of 4-hour target compliance and long stays in A&E and trolley waits and so on, is acute medical unit. Now, as we've already discussed, when patients are done in the acute medical unit, so back in the day that used to be a length of stay of 24 or 36 hours. These days it's often a bit longer. They then go on into the specialty wards, or maybe, I don't know, 60% of them do. Again, these percentages will vary from hospital to hospital, but that's not a bad rule of thumb, that 60% of acute medical patients will go onwards into the hospital and 40% will go home. And you can see that what I've done with these boxes now is I've also put in some sort of kind of orangey brown coloured delay strips, because this is how the unscheduled care pathway is characterized every step of the way. So the one that most people think of when they think of exit block is that first one on the left, the strip in the emergency department box. That's the one where we get the which generates the crowding in an ED, which is at the root of all of these problems. When patients are ready to leave the ED, but they can't because there's no bed available for them, and we get these queues forming in the ED, and we get all sorts of horrible dysfunctional feedback loops. So not only are the patients who are bound for a ward delayed in ED, but because these are the patients at the sicker end of the spectrum in the ED, they still need to be cared for by ED staff. They're still taking up space in the ED, so they therefore compromise the care of the less sick, non-admitted patients, and so it goes on. So the problems caused by the exit block, caused by wards being full, are really bad, cause a lot of dysfunction. We also have similar delays in the acute medical unit. These are harder to measure because we don't really have a target for this, but you speak to any consultant in acute medicine or any charge nurse in an acute medical unit, and they will tell you that at any one point in time, there will be patients occupying beds in the acute medical unit who needn't be because they're ready to go. They're ready to go into a specialty ward, but they can't because the specialty wards are full. And that's not even I suppose if we go back to 20 years ago when things were a lot better, very often that problem would be, oh, we've got a cardiology patient, we want to move them to a cardiology ward, but there isn't one, so we'll hang on to them until there is one. More often the situation is there isn't a ward of any description. So we can't even move a cardiology patient into a medicine of the elderly ward, or we can't even move a gastroenterology patient into a respiratory. They're all just full. So that causes delays. And of course, we all know that one of the reasons why specialty wards are full is because they experience, now these are delays that we measure. These are very often delayed transfers of care, delayed discharges, people waiting for care home placements, people waiting for packages of social care to be arranged and so on. So we've got delays there. And the crucial thing that I want to sort of really talk about today is this delay here. I've got a grey box there that says it's this ED to AMU handover, which is where exit block is really writ large. Right, now section 3, the flowology grid. So as a way of conceptualizing and thinking about how we can apply data and how we can bring data to bear on this problem of patient flow, I came up many years ago in conjunction with the data analysis team in NHS 5 with the idea of describing it as a grid. So it's not fantastically big, but maybe if I use the plus sign, I can make this a bit bigger. There we go, not better. Right, so the three columns in this, A&E assessment and wards, approximately are analogous to the previous slide. So the A&E department, ED assessment. In this particular example, it's not just the AMU, it's also surgical assessment. I think this is a grid from a different hospital. And then the wards is all the wards, not just the medical wards, but surgical, the whole shooting match. And what I've got here is a grid that's just for one particular day. I've no idea, it's ages ago, 25th of November. And it's a day you can see from that red strip, which was 70% compliance. Now, I know that most hospitals in the UK these days would kill for 75% compliance because that would in 2025 be considered to be brilliant. But back in whatever it was, the mid 2010s, when I think this data was from, that was terrible performance. So this is supposed to represent a bad day in the life of the hospital. And about 10 years ago, myself and Professor Mohammed, we did a whole series of workshops up and down the country where we would have this kind of simulation replay thing called Flowopoly, and where we would replay a bad day and a good day. So this is taken from one of those Flowopoly exercises, and this is a bad day. And one of the things that we were keen to get people to do, and they often did this of their own volition, is to work out how these numbers in this grid were related. So we've got an A&E column, we've got an assessment column, we've got a wards column. What are these three metrics that we've got down the left-hand side? So we've made them we've given them user-friendly names, how many, how long, how full. So you can see, I mean, most of you are data analysts, you're going to get this in a trice, you've already got it. How many is basically the activity measurement. So in A&E, that's attendances. For the assessment ward and wards, we count them as admissions. And these numbers are for one particular day. How long is length of stay? So those 166 attendances in A&E, on average, they were in for 240 minutes. So the average length of stay was 4 hours. Okay, which is obviously rubbish because they're all supposed to be done in 4 hours, and this was the average, which is why we've got 70% compliance. The average length of stay in assessment was 22 hours. That's pretty good. Again, most AMUs and surgical assessments would kill for that now. And how long length of stay in the downstream wards? That's always going to be hugely variable. That was the length of stay of the patients who happened to be discharged on that day. It was 4.6 days. And then we've got fullness. So on average, the A&E was 25.7 patients full. So the way that we count that was this idea of successive snapshots. So a snapshot every hour. I think possibly with A&E, we might have got into the habit of taking a snapshot every minute. So how many patients are in each minute and then averaging them for the day. I think with assessment and wards, we just take one snapshot every hour and take an average. So it's not a midnight snapshot or a midday snapshot. It's an average of a load of hourly snapshots, if you like. And one of the things, so that's how we get these numbers. And those of you who've done a bit of operational research will know that how many, how long, how full are basically kind of I don't know what to describe. They're kind of like, user-friendly names for the components of the Little's law formula. So if you look up Little's law in Wikipedia, you'll see that it's I think the way that it's usually formed is L equals lambda times W. But if we sort of switch those around a bit, how many is lambda? How long is W? And how full I think is L. I think I've got those right. So lambda times W equals L. This never comes easy to me. But basically what we're saying, again, a lot of data analysts who work with hospital data, even though they've never heard of Little's law, they still know almost instinctively that admissions multiplied by length of stay equals occupied bed days, which is effectively what we're counting here. And it's important for analysts to have that sort of arithmetic component to this grid. A lot of service managers and clinicians aren't that bothered about it. But what they do get straight away is that there is a sort of what this grid enables them to see is a relationship. So if this was a bad day, what a lot of them will do is say, well, this was a bad day because of that figure in the bottom right. So if this was a hospital that only had, I don't know, 415 beds, okay, what we're saying is that on average that day, it was 411 patients full, right? So on average, they only had 4 empty beds to deal with vast amounts of throughput, elective, non-elective, the whole lot. So this was a hospital that was too full. And then what they would say, well, the reason it was too full is probably because so that sorry, no, I've got my cause and effect the wrong way around. That fullness was making the fullness of the AMU fuller than it should be. So supposing that the AMU that we've got that value of 49.1, supposing that AMU only had, I don't know, 52 beds, or the assessment area only had 52 beds. So again, that was too full, and that was making the length of stay too long, okay, because patients were waiting in there because they were waiting for the downstream beds. And the AMU fullness was causing the ED to be full. So this again, these were conversations that Mohammed and I would watch people sort of they would first of all replay the day and they would see them doing the sort of post-mortem on it, and this is what they would do. The downstream wards are too full. That means that the AMU wards are too full. That means that the ED is too full, which means that the length of stay is too long, which means that we get terrible compliance. So we get this sense of this grid having a chain reaction in it, which I've tried to do on the next slide, which probably won't. So now I've done that magnification thing, I'll now need to demagnify, won't I? That'll get me back to. There we go. There we go. Right. So I can't really magnify this. So hopefully you know what those numbers are. So the chain reaction is that the fullness of the downstream wards causes the fullness of the AMU, which causes the fullness of the ED, which causes length of stay in ED to be too long, which causes compliance to be too long. Again, there are nuances to this, and again, we're going to come on to them in a few minutes, but that's the general gist of it. And that's a sort of way of thinking about patient flow that this grid enables. The gold run. Yes, you've been thinking about the gold run. So again, if you are old, this will bring back memories. Those of you who are not, I thought, gosh, better look it up in Wikipedia. So there was this game show, saying Channel 4, it wasn't Channel 4, it was on ITV. Crikey, that is a long time ago. It first aired on the 29th of August, 1983, would you believe? No idea if any of you can remember this. It's etched on my mind because I was still, I was conscious in 1983. And one of the things that people will remember about the Golden, it was school age kids, like teenagers that used to do this, and they had a host called I think he was called Bob Holness. He was called Bob anyway, and the kids, you get the idea. I think I've got a picture of it here. There we go. This gives you an idea of how it works. So there was this kind of honeycomb, hexagon grid thing in the background, and then they would have to answer questions. And at a certain point, there was this gold run challenge thing, where they had to get from one side of this hexagon honeycomb to the other. And they would get asked these questions. And it was just this idea that this was so always for me, it always seemed like it was like a chain reaction. So you could sort of ignore all of the other green hexagons, they weren't relevant. So it gave me this idea when I came up with that grid that we could actually redesign that grid in the spirit of blockbusters. So those are the same 9 numbers. This is just the most ridiculous flight of fancy you've ever seen in the history of healthcare data analysis. But those 3 numbers down the left, that's A and E. The 3 in the middle, the vertical sequence in the middle is assessment, and the 3 are the downstream wards. And then the gold run, there you go, there's the gold run. So occupied beds in the downstream wards leads to full occupied beds in the AMU, which you get the idea. And then it did occur to me as I drew that actually it looked a bit like a turtle, which then just kind of, it lost all credibility then. But anyway, gold run for me is quite a nice metaphor for thinking about that chain reaction. Right, enough of that. Let's think about this fullness hypothesis and why the fullness hypothesis is dead and why we're going to have to turn to heaviness. So far, okay, according to whether you're looking at the turtle or whether you're looking at the actual official grid, we've basically got a sort of theory of patient flow that says that it's fullness. It's fullness that's the problem. Fullness in the downstream wards leads to fullness in the AMU, leads to fullness in the ED, and that's the whole thing. It's all terrible and it's tragic, and we need to do something about it. The problem that we've got is that as systems become more and more dysfunctional, so this has been the case particularly since we started recovering from the pandemic. So there was this kind of horrific sort of hockey stick graph that happened to sort of 4-hour compliance and 12-hour compliance in all of the nations of the UK, starting in about the summer of 2021, that persisted right through until for the next 18 months. And we've barely recovered since then. And we've now got this system, we've now got hospital systems that are now severely dysfunctional. And one of the things that that I discovered, and it came out of one of the training courses I did, which is visualizing statistics, where we were looking at correlation. And I'm going to talk you through the reason why fullness hypothesis is possibly dead, using some examples from that. Now, first of all, as a bit of context, let me show you this. This is the same hospital, but about 4 years apart. And what we've got here is 2 graphs, which are they're both looking at the same variables, but obviously different time periods. Let's concentrate on the one on the left. Each dot on this graph represents a week. So it's 2019-20, the financial year. So it's the year that ends with the beginning of the pandemic. So that I think COVID-19 sort of started in March 2020. So that one or two of these weeks will be COVID affected, but the rest of it will be a relatively normal year. The 2 axes, what we're measuring on the vertical axis, which is coloured red, we're measuring 4-hour compliance. And on the horizontal axis, coloured blue, we're measuring the occupancy of the AMU. So what you can see is that there is a fairly, it's not absolutely, ramrod straight, but there's a top left to bottom right relationship there, which allows us to say that yes, in general, looking at it week by week, the fuller the AMU was, the worse the 4-hour compliance was. Okay, and what I've done is I've drawn those sort of set square lines, the blue vertical line and the red horizontal line, to represent the averages for each of those values. So the intersection of those tells us what the performance was for the whole year. So the intersection is about what? About 82% compliance, something like that, and something like 87% bed occupancy. So those were the averages for the year. And you can see that whenever the occupancy was higher than that, the compliance values were nearly always lower than the average. So you can see that most of that data splits into just two quadrants, top left and bottom right. And that's that relationship.
And
But
this
if you
particular
fast forward,
organization is not
oh, sorry.
stickers and
Oh,
brown shirts. You know,
is that a question or is that just a bit of
I think somebody needs to mute.
all right, okay. So if you fast forward 4 years, so this is the I'm finally getting to the point. It's taken me about half an hour, but I finally get so is that so we're now into the dysfunction years. So this is 2023, 2024, same hospital. And one of the things that you notice is that all of the dots have moved. There's almost no overlap between these two graphs, even though it's the same hospital. And the activity levels are broadly the same. Not only have they moved so that there's no overlap between them, but there's now almost no relationship. Okay, so those dots in the right-hand graph, which are all kind of clustered in the bottom right of that graph itself, that's just like paint randomly spattered on a wall. There's no pattern there. There's no relationship between the fullness of the AMU and 4-hour compliance. It just seems to be random. And you think, oh my God, what's happened? Why has this happened? And then you realize that what's happening, have a look at where those dots are clustered in relation to the blue horizontal axis. Hardly any of those dots represent a week where the AMU occupancy was less than 90%. Now, AMUs, even large AMUs like this, which I think was a sort of 60-odd bedded one, they can't really function unless the occupancy is below 90%. If you have a look at the graph on the left and have a look at the good weeks, so the weeks that were in the sort of top left quadrant of that, where 4-hour compliance was above sort of 85%, you can see that they were associated with weeks when AMU bed occupancy was sort of 85% or lower, right? That's what AMUs need to be operating at. The lowest they ever got was about 90 in that year. So what we're now moving into a situation is when what happens when the beds are just always full? And when we did the visualizing statistics examples, this is a sort of an exploration of correlation. This is what we found. So when we look, so I'll need to explain this because I haven't labeled things very well. I think this is the same hospital, 2023-24. And what we're measuring on the, we've now got daily data instead of weekly data. That's why there's more dots and there's a lot more overlap and clustering. What we're doing is we're saying how many beds are occupied in the AMU along the bottom. So in fact, I was right. It was an AMU that had, I think, 68 beds. So you can see that those green dots never really go beyond 68, which is good. That suggests that the data was in pretty decent shape. And then on the vertical axis, we're measuring the average length of stay in the ED of all the patients on that day. And what you can see from this example here is that there's not really much of a relationship. I mean, there is a relationship. What we're saying is that because there is a small amount of slope to that trend line. So in general, the fuller the AMU, the longer the length of stay in the ED. But that R value of 0.2, that won't get you anywhere. Most people would say there's no relationship, get yourself, just, get a grip on reality. That's all ED patients. If you restrict this and so say, well, what if we just restrict this to just those ED patients who need to be admitted and look at their length of stay? Does that make the relationship any better? To which the answer is, well, yes, it does, but only a small amount. So what we've done here is we've said, so the data along the bottom axis is still the same, but we've restricted this analysis just to the mean length of stay of those patients who end up being admitted. And we get a better R value. What we then do is say, well, what if we then restrict it to those patients who are admitted to the AMU? Okay, so it's now as if we're sort of denying all of those feedback loops that I mentioned earlier. Does it improve the R value? No, it doesn't. It changes the look of the graph, but it doesn't change the R value. So we've still got this very frustrating position where You can have conversations with coal-faced people in hospitals, doctors, nurses, AHPs, service managers, bed managers, discharge coordinators, and they will all tell you that, you know, fullness is the enemy. And yet the data, it doesn't seem to bear it out anymore. What we then did is we said, right, okay, here's an idea. Let's, instead of looking at the fullness of the AMU, let's have a look at the length of stay in the AMU. So this was inspired by conversations I've had with some clinicians who said, we were talking about sort of everyday bed management, and they said, oh, they always think of beds as being split into two types. They said there are active beds and there are inactive beds. And if a patient's been in a bed for longer than, you know, I don't know, 3 weeks, we don't count it because the chances of that becoming available later on today are, you know, almost zero. Whereas the other ones are probably more associated with a bit of churn. Okay, now there's a bit of science attached to that, but I was quite taken by the fact that this was a coal-face generated hypothesis. And I thought, oh, I wonder if length of stay has got something to do with exit block. So what we did with the next graph is we said, rather than look at the number of beds occupied in AMU, let's have a look at the length of stay of the patients in AMU on that particular day. Okay, so are you ready for this? This is a kind of theatrical moment. So this blue graph now gives us a really good R value. So 0.71 is a pretty good correlation coefficient. I mean, that'll get you published. What we've got here is that, and I've called this measure ALO-SSF. So that's average length of stay so far, okay, in AMU. So each of these dots is a day in whatever year it was, 2023, 24. If you take that leftmost dot, can you see the leftmost dot? Its horizontal value looks as if it's about, what, 12, something like 16, 17 hours. And the horizontal value is something less than 480. What that means is that patients on that day, on average, their length of stay up to the end of that day was about 16 or 17 hours, okay? As opposed to a patient over on the right-hand side of the chart where their average length of stay so far was, you know, 2, 3, almost getting on for 3 days, or 2.5 days, okay, 60 hours. So it's a measure of length of stay at the moment. And then what we said was, well, let's multiply length of stay by the number of beds occupied to get some proxy of bed days and see if that improves it, which it does. We've now got a purple graph, but only a bit. But that doesn't work because this gets us to heaviness. So what we've now done is we've said this value that we've got on the horizontal axis, for now, we've got a good correlation, is basically saying what happens when you multiply the fullness of the AMU by the length of stay so far of the patients in the AMU. And that gets us heaviness pass. Right, now, the last bit, this will take 2 minutes, and then hopefully that'll give us time for questions. Let me just skip over that, because we've already seen that. Let's get into this one here. Right, so let's just think about how heaviness plays into the chain reaction. And let's have a look at this hospital, and we're going to look at some barcodes. So barcodes have become my new favorite way of visualizing things. Hopefully we'll get the hang of this if I can mediate this. We've got 366 days of 23-24. So there was 29 days in February in 2024. So that's why there's 366. And what I've done with this barcode is I've arranged them all along a horizontal axis, which is measuring length of stay in A&E in minutes. So effectively what we've got is the average length of stay per day of ED attendances. So the best day on the left was a day when the average length of stay of all the patients on that day was about, what, 190, 200 minutes, something like that. And the worst day was the day on the right, when the average length of stay of all the patients who attended that day was 540, which is a long time. That's crikey, that's a crazy amount of time. That's the average length of stay, guys, right? So this is a year that encompasses a lot of variation. And the average is the black solid line there, which looks as if it's about 340 minutes or something like that. So again, very dysfunctional. Now, what I'm going to do is I'm now going to split this barcode into 2 barcodes, a red barcode and I think green, but it might be blue, but you know, I can't remember. Where what we're going to do is we're going to say, right, let's, well, let me just explain it here. what I've done is I've split it into into two types of days. The blue barcodes are the days when the AMU was less full, and the red barcode is for those days when the AMU was more full. Okay, so I've basically split the data set into two halves, two equal halves. So there's 183 days in the top barcode and 183 days in the bottom barcode. And whether that line is in the top barcode or the bottom barcode is determined by what the occupancy of the AMU was on that day. So the blue lines are the AMU was emptier, the red days are the AMU was fuller, okay? And you can see that there is a difference, okay? This is effectively showing those correlations of 0.24. It's not much of a difference, okay? But if we go for heaviness as our measure, can you see that we get a much more significant difference between them? So what we've done there is we've said, let's split those 366 days into two, so 183 blue, 183 red. But this time we've allocated them to blue or red, depending on the heaviness of the AMU. So it's the fullness multiplied by the length of stay so far of the patients in there. And then what I've done, I think I've done this. Oh no, I haven't done this. This is like, and then what I did finally is I took the same logic of heaviness and lightness, I suppose, and said, what about that final stage in the flow, so within the hospital? So the flow from AMU into the specialty beds. And this was the one where I started, I think I looked at all three types of heaviness, like light heaviness, future heaviness, present, would the whole shooting match. So let's have a look first of all at ED performance when the specialty beds. So this is the bulk of the beds in the hospital. So in this hospital, I think this hospital was a big general hospital where there was about, I don't know, 800 beds. So what we've got here are on the blue barcode are those days when those 800 beds were more full. So I don't know, I'm going to guess maybe on average, like, 97% occupied. And the red, sorry, I'll start it off. Sorry, the blue barcode, I'm sorry, is when they were least full. So that might be, I don't know, 92% occupied on average. And at the bottom, it's more full. Okay, maybe 96, 97. Again, there's a difference. But when we start to bring heaviness into the equation, we can see that it starts to open the gap. So this is specialties lighter and specialties heavier. This is heaviness past. Okay, it's better than if I go back to the previous slide, we get a bigger gap than we did with just measuring fullness. But here's the thing, this is what sort of surprised me, is that when we look at heaviness future, the heaviness yet to come, it widens even more. So what we're doing here is saying, what about the length of stay of the patients occupying beds that's yet to pan out? If we separate them according to that, what we find is that is what really seems to be determining what happens to ED performance. So it's this fullness mitigated by a length of stay. Why it might help, this is the last slide, is that if I go back to that grid, or I've taken a kind of a subset of that grid here, okay? So this is an example, again, this is from a different hospital, where I'm saying if you're a downstream specialty of general medicine, so I've called it post-AMU general medicine, and we've got our three metrics down the there's three rows, how many, how long, and how full. So that first column, which I've called what is, that was the status quo for whatever year it was, 2023, 24. 6.4 admissions a day, average length of stay 9.4 days, how full 60.2. That's no good. This specialty had 55 beds, so they were almost always overflowing, boarding into other specialties. So what you can do is sit down with that specialty and say, well, what ought your numbers to be if you were to have a go at living within that envelope of 55 beds? So what we've done is we've started with a value of 49.3. There's a bit of, finger in the air and let's have a guess, but that gives us a level of occupancy that's, I don't know, about 90%. And then we say, well, you'll only achieve that because of what we know about the Little's law arithmetic. If you could either reduce your admissions or you can reduce your length of stay or both. And what it seems to me that where heaviness helps in this equation is it enforces or reinforces this idea that people have got to look at all of these three metrics together, length of stay and fullness. So there we go. I'll stop there. We've only got 7 minutes, haven't we, left for questions there, but I'll stop sharing my screen and over to Rachel.
Thank you, Neil. That's really interesting. So So what I'm just trying to think. Well, I'd be interested to see how people have received that information, whether it was useful to them, because you, like you say, it's kind of you're working on, and I've worked with sort of clinicians and people who sort of the coal face. You've been trying to find ways that they would understand this. So sort of
Yeah,
language, and so not numbers and stats as such, but this is like you want to be able to feel what they're feeling when they look at a ward and so on. So there's
yeah,
a bit of that in this, but I think there's yeah there's so you want our guys here to help you with with how you've described it. Is it useful and everything? So is that right?
that's
Um,
right.
so there aren't many questions yet. So but that's fine because we haven't got loads of time. Um, oh, there's somebody who's just somebody who just needs to mute themselves.
Hello.
Uh, hi. Do you have a question? So we do have a question. Shenyu. You do need to unmute yourself. I think someone's muted you.
Yeah.
Hi.
Hello.
Hi.
Yeah. Thank you. Yeah. Thank you so much for the presentation. Very, very interesting. A quick question. And how we can bring your research into life? How you're thinking to imply some of your findings in our practice? What you found is length of stay has more impact on the
And what happens in the ED than
yes,
just looking at the
the
fullness. Yeah.
fullness.
So
Yes.
yeah. So
So I'm trying to think about the next step. So if that is true, how we are going to utilize the findings into the practice and giving clinicians in the hospital some advice in terms of what kinds of measure you should use and what kinds of intervention you should put in place in order to reduce the length of stay in ED.
yeah, very good question. The only progress I've made with that is that so I often use X or Twitter as it used to be known as my sounding board when I have ideas like this because that's where a lot of doctors still hang out. So I managed to so when I aired this first back in June, I sort of I tagged a lot of acute medicine consultants and ED consultants and said, guys, what do you think? And to my surprise and astonishment, most of them said, yeah, we can see what you mean. But then none of them adopted it. None of them, none of them liked it so much that they said, "Oh, show us the code" or anything like that. So there was a kind of affinity with it. But what you were really getting at, Chenyu, I think is but how can they operationalize that? And I think that is tricky because what you've got to do is you've got to say to people in AMUs and people in wards, you're not just looking at the fullness or the occupancy you're looking at the occupancy as it's kind of mitigated by length of stay. So you're going to have to, we've got to somehow get this measure of heaviness, whatever they decide to call it, somehow into the kind of lingua franca of people's conversations, which I accept is very challenging.
Okay. So we have some work to do there.
Yeah, I'm still thinking how to transfer that into a measurement we could measure like
Yeah,
on
and
the
I think
daily
I'd like a
basis.
better
I'm
name.
trying to,
Yeah.
yes.
I mean, in a way, that would be. If I could do that, I would kind of think that's my work done. If I can, if I have it so that we have acute medicine consultants and specialty consultants, and people say, "Oh, what was your heaviness today?" then we'll be cooking on gas.
Okay. Thank you, Jenny. So a couple more questions. Next one, we might go over time. People, we are recording this, so if people, but we will. Are you okay to hang on for a second, Neil? just for a few
Yes, I'm
minutes?
fine. I've got no problem with that.
Brilliant, brilliant. Ed, you've got a question. What's your
Yeah,
question?
Ed Mitchell, I'm the Deputy CMO at Worcestershire Acute Hospitals. To answer your first question, I'd suggest burden of illness as an alternative term for heaviness, because you're looking at how much sickness there is in the population, assuming sicker people stay longer, multiplied by the number of
Yeah,
patients. So
good
burden
point.
of illness is I'd use that to describe it. I think that the difficulty with the operational implementation is that we're all humans and have relatively simple brains. We can only keep one metric in our mind. So while we're talking about beds, we're talking about individual patients, and often capacity management is talking about individual patients and moving individual patients on their individual journey rather than thinking about the whole hospital system. I can absolutely see, and maybe this sort of might help Shengu's thoughts. I was sort of imagining a dashboard that describes the hospital day by day and shows where the pressures are. So you come into work on a Monday, what's the problem? The problem is that the burden of illness on the specialty wards is high because you've got a high length of stay because no one's been discharged over the weekend. So what's the priority for Monday? Priority for Monday is to reduce the length of stay on specialty wards. So get out there and get discharging. By Tuesday, the AMU's getting fuller again and the patients are staying longer there. So maybe put more focus into the AMU processes and and take it from there. So trying to use it to inform the capacity hub or the capacity management team and clinicians about how much burden of sickness there is in the hospital, and here's the area where we need to focus. And it goes a little bit beyond just discharging people, which of course is what we always want to do, because a patient who isn't there can't generate any burden of illness or heaviness in your terms. So obviously discharging people is a very efficient way of bringing the number of burden down.
I like that a lot. Thank you, Ed, because what that phrase brings to it, burden of illness or burden of sickness, is it helps to bridge the gap, which you also alluded to, between thinking about patients one by one and thinking about patients as a generality. And I think that's quite a nice way of, A, it's a better way of describing it than heaviness, and B, I think it helps to bridge that gap. So I do like that suggestion very much. Thank you.
Thank you. We had a note in the chat saying a possible way of describing it, which is similar, is morbidity load. So again, relating to sickness and levels of illness, a similar feel. A couple more questions. Jonathan, you have a question?
Yeah, thanks, Neil. If you take the number of people and their length of stay, when you put them together, it gives you total bed days. So I think what you're describing is heaviness as total bed days, well, hours. So I was just interested as to why you didn't use that. It's sort of commonly accepted term.
Yeah, it's because I think it's because when I started messing around with it, I was taking incomplete stays. So my understanding of it from my sort of heritage in data analysis in healthcare was that occupied bed days, you were always calculating them on the basis of completed stays. And I think that was I think possibly why I shied away from it. It's interesting because there's a guy I work with, Matt Oakes in Sherwood Forest, who's been, about every 2 months he says what you just said to me. He keeps nudging me and said, Neil, it's just occupied bed days. And occupied bed days is the most crucial thing in this because it combines everything. So at some point, you're all going to persuade me to just say, do you know what? I'm just going to call it occupied bed days.
or maybe hours.
Occupied, yeah, for AMU or even minutes for the ED as well. Yeah.
Thanks very much for that. And I think we'll get there in the end. We do need to be understood, and sometimes you want to be able to present things in a different way so people can get the picture. I think we've got Matt Oakes on next time. Actually, I'm sure I've invited him to be a Huddle presenter next time. So, David, you have a question?
Yeah, Dave Watson from UHL. Leicester Royal Infirmary is our major ED. So we've come to this kind of thing via a different method. Basically, finance has asked a question. Your activity growth from X to Y has grown by, let's say, 5%, but your cost has increased by 25%. Let's just say, for argument's sake, these not exact numbers. why is this? So what we had to do is basically say, what are our total patient hours within ED? So obviously activity has gone up by slight, but actually our total patient hours has gone up by, let's say, 40%. So actually, if you did it by cost per patient hours, actually we're more efficient than we were, let's say, in 2019 COVID than we are now. And that's how we've kind of used heaviness to explain why our costs have gone up, because we need to provide patient care for longer in the ED department, because they're staying there longer because of all the blocks you've just mentioned. So that's how we've kind of come to the same conclusion with using heaviness, to use that as a metric to kind of explain that story, which finance have posed us. I don't know if that's of any help.
No, it is. And it's really interesting, because many moons ago, and probably this must be 25 years ago, I was involved in, when I was still a salaried NHS information analyst, I was involved in the planning of a PFI hospital. And one of the things that the PFI contractors wanted to do was create a new metric that would translate into resource use, whether it was facilities management or cleaning or whatever it was. And we came up with bed occupied units. What's so similar is that it was finance driven, and it leads to this same measure. So yeah, so there's a moral, isn't there, which is like we should pay more attention to what the accountants are telling us. Thanks, Dave.
That's really helpful. Thanks. So there's no more questions. There was a point in Menti just about, really, it's about that practical application. So understanding how this can be used to change things, to improve flow, essentially, which is what this is all about. So thank you, Neil. We've gone slightly over time, and I'm fine with that. My tummy is rumbling, and I'm just going to, for the people who are still here, there's loads of people still in the room, Neil. You're the popular guy. Let me just put that up to here, and I can, while I just put that on the screen, I'll just say thank you so much for coming in. If people enjoyed hearing Neil today and want to quiz him further, then you're going to be joining the AFA lunch and learn session in December, aren't you? So you're going to be, there's going to be Neil again in December. But no, that's really interesting, and I think you've had some good feedback on how this might be useful to how you see things. So here's a slide on what's coming next. Not quite in the right order, but we have got Matt Oakes. I wasn't making it up. So we do have an analyst's perspective on the federated data platform. I know that's going to be very interesting to a lot of you. And we do have Stephen Wyatt then talking about the impact of NHS waiting on patients' decisions to have private treatment. And then we have the Health Foundation with Tom Prendergast, and he's going to be talking about waiting list MDS, and just moving on to a couple of training opportunities that we have coming up. And of course, I do want to mention, and probably will re-mention, the Health and Care Analytics Conference on the 3rd, 4th December. It's online. I'll just show you who we got lined up in a second or two so far. We have our regular wrap sessions with Chris Bealey. We have just mentioned the AFA fortnightly lunch and learn sessions. She's such a copycat, and that's absolutely fine. And the understanding and reporting hospital mortality statistics, we are definitely getting some dates lined up for that as well. And I thought there we go. So here are the confirmed speakers in Hacker so far. So we've got Stephen Wyatt. He's coming to. You'll have met him if you come to these huddles regularly. And we've got some other really great speakers coming to help shape the program very nicely for Hacker in December. So I won't read them all out. And we also we're just going through all of the. Just stop sharing now. We're going through all of the abstracts now. So that's what my next thing to do is to sort of chase people who are reviewing the abstracts for us, and then we can really start to pull that program together. So thank you again, Neil, for hanging out with us today. I really enjoyed that. And thank you everyone for coming. And I'll see everybody in approximately 2 weeks. Thanks very much. Bye-bye.